Today we're going to solve by factoring, and we can use this method when we see one or two x's. By that I mean I see two x's here, so that's two x's, or we see one x but it's to the second power. That's when we're going to typically solve by factoring. The first step is to get an equation equal to 0. These first four examples are already equal to 0. Then we factor if we need to. Now these first two examples are already written in factored form. Remember, factor means to write as multiplication. These other two examples we're going to have to factor first. Then we are going to set each factor equal to 0 and solve. We may have more than one answer. So typically if our exponent is 2, we're likely to have two answers, not always. The reason this works is because of this idea right here. If A times B equals 0, if two things multiply to be 0, what do we know about A and or B? We know that one of them or both of them must be 0. This is called the zero product property. So when we're solving these equations, we have to have our equation set equal to 0 in order for this property to be helpful. So for our first example, we have x times x plus 8 equals 0. So our first step, get an equation set equal to 0. We do that. Factor, this is already written as multiplication, so we don't have to factor. And now we set each factor equal to 0 and solve. So I'm going to take x, that's my first factor, and set it equal to 0. And I'm going to take x plus 8 and set that equal to 0. X equals 0 is already solved. We know one of our answers. X plus 8 equals to 0. I can subtract 8 from both sides, and I'm left with x is equal to -8. And that is, that's my other solution. You can plug these back in just like you do for linear equations and check to see that you do and get 0, whether I plug in x is 0 or x is -8. Taking a look at the next example, again, set equal to 0 already. Factored, I've already written this as multiplication. Now I'm going to write each factor equal to 0 and then solve. So for the first equation, I'm going to add 6 to both sides, so I end up with n is equal to 6. The second equation, I have add 4, so I'm going to subtract 4 from both sides, and I get n is equal to -4. So these are the two answers that will make this equation true. So if you plug those back in, you will get 0 equals 0, so the equation works. And you can see I did a check right here. I think checks become more helpful when you check back into your polynomial form to make sure that you factored correctly. So taking a look at part C, we need to first factor. We have our equation equal to 0, but we don't have it written in factored form yet. It's not written as multiplication. So take a moment, pause here, and factor this. So we're looking for factors of -18 that add to -3. So you can do your whole systematic list. The bigger number has to be negative so that the middle term is negative. Or some of you might have jumped right to that factor pair of 3 and -6 because you're familiar with this. And if you're using the box method, you can write it out as the box method. You can also look here, how do I get x squared? That's only x and x. And now we know to get 18, because our leading coefficient is 1, we can just put those factors in right here of +3 and -6. And of course, we can check that x times x is x squared, which we have. 3 times -6 right here gives us our -18. And then the outside here, I have -6x. Inside is 3x, which does make the -3x right here. And this equation is still set equal to 0. Now we're at where we were on our previous examples where they're already equal to 0. So now we're going to set our factors equal to 0. X plus 3 equals 0 and x minus 6 equals 0 and solve from there. So we're left with x equals -3 or x equals 6. And those are our two answers. So when I check these, I like to check at the beginning, right in my original polynomial. So I just pulled a sticky down so we can do some checking. You're going to plug one of these values in for x, so negative 3 squared minus 3 times negative 3 minus 18. Does that equal 0? And negative 3 squared is 9. Be very careful putting that into your calculator that you get a positive 9. Negative 3 squared, if you just put it in without parentheses, you just put it in as negative 3 squared, you will get negative 9 on most calculators. But the answer is actually, when you're meaning to square the value of negative 3, the answer is actually positive 9, because negative 3 times negative 3, two negatives make a positive. So here, negative 3 times negative 9, negative 3 times negative 3 is positive 9 again. And we have minus 18. And so 9 plus 9 is 18. Minus 18 is 0. So yes, 0 does equal 0. It is a check. When we're checking the other number, we're plugging in 6. So 6 squared minus 3 times 6 minus 18. 6 squared is 36. Minus 18 plus 18. Minus 18 minus 18. And 36 minus 18 is 18. 18 minus 18 is 0. So this checks also. But this is just a safeguard to plug back into the original to make sure we haven't made a factoring mistake. So look at example D. We have n squared minus 9. You might recognize this as the difference of squares because 9 can be written as 3 squared. You might also think of this as n squared plus 0x minus 9, and think of the factors of negative 9 that add to 0. Those are going to be 3 and negative 3. Either way, you should get n plus 3 and n minus 3 as the two factors. These would all be equal to 0. And then set your factors equal to 0 and solve. And we're left with n equals negative 3 or n equals positive 3 as our two answers. Let's scroll down and look at the bottom examples. These last three examples require more work because none of them are equivalent to 0. None of them are set equal to 0. So we have to do a little bit of algebra to get it in that way. So for the first example, I can subtract k from both sides. And notice I'm lining up my like terms. K minus k is 0. So 7k squared minus 21k. And we haven't talked about this, but the first thing we always do when we are factoring is to scan for greatest common factor. And I can see that I have a greatest common factor of 7 and k. So I'm going to factor out the 7k first. That is going to leave k for my first term right here, and it's going to leave minus 3 for my second term. So I'm actually already factored with my greatest common factor. So I'm going to set each of those factors equal to 0. And if I divide both sides by 7, I'm going to get k equals 0. So I have k is equal to 0. Here, if I add 3 to both sides, I get k equals 3. Of course, you can check those. I'm not going to do that on the video. Looking at example F, it is the same situation where I have something on the right and I want to have it equal to 0. So I can subtract 8 from both sides. Again, I'm subtracting and I'm making sure that I line up my like terms. So the 8 goes with the 12, and so I'm going to line that up there. And I'm left with 3x squared plus 7x plus 4 equals 0. So I need to look for factors of 12 that add up to 7, and that's going to be 3 times 4. I recommend doing the box method often when you have the leading coefficient other than 1. So using the box method, in my first column, 3x is my common factor. In my second column, it's 4. In my top row, just an x factors out, and in my bottom row, it's just a 1. So my factors are going to be 3x plus 4 and x plus 1 equals 0. And we can still do, like if you didn't want to do the box method, you are looking at factors that make 3x. Well, only 3x and x make 3x. For the last terms, it could be 4 and 1, or it could be 2 and 2. And remember, you're trying to get your product to be 3 and 4. So with 3, you know it has to be 1, which leaves 4 to be here. So 2 and 2 would not work. Now we're going to set those factors equal to 0. 3x plus 4 equals 0, and x plus 1 equals 0. We're going to subtract 4. This is the first time we've had a two-stepper. 3x equals negative 4. We're going to divide both sides by 3, and we get x equals negative 4/3. You're going to leave this as a fraction, and then this other one, we're going to subtract 1 from both sides, and we get x is equal to negative 1. So these are our answers. I never boxed these other ones. Let me go ahead and do that. The last one, pause and try that on your own. You are going to add 3 to both sides. We get 5n squared plus 9n minus 2. So we're looking at factors of negative 10 that make 9. That is going to be negative 1 and positive 10. And so again, you can do the box method, or you can use your 2 parentheses. You get your factors to be 5n minus 1 and n plus 2 equals 0. Set those factors equal to 0 and solve for n. And you're left with n is equal to 1/5, or n is equal to negative 2.